All right, let's look at number 3 from the 2021 AP AB exam. And this is the one that I have read a lot about. It's the spinning toy problem. So companies designing spinning toys, we have this horribly ugly function, and they threw in some unknown constant C, which I have learned a lot of students automatically make that painful, even if it doesn't have to be, those unknown constants. Okay, so C is a positive constant. I guess I'll make a note that C is greater than 0. The figure above shows the region in the first quadrant. Spinning toys shows they're revolving around the x-axis to create the entire shape. It's going to look like a little teardrop. Okay, find the area of the region in the first quadrant for C equals 6. And we will need to know when it hits the x-axis. So in the first quadrant, if we set this equal to 0, that's going to equal 0 at x equals 0, 2, and technically negative 2, but that's not a 2, technically negative 2, but we're in the first quadrant. So the area in the first quadrant when C is equal to 6. So part A, that's going to be the antiderivative of 6x, 4 minus x squared to the 1/2 from 0 to 2, and this is a good old U substitution problem. We will let U equal 4 minus x squared. du is negative 2x dx. I think I'm going to grab this 6 out of the way, put it in front. And then I need to create my du, so I'm going to put a negative 2 in here and divide by negative 2 out here. And when you substitute this, you'll end up with negative 3 on the outside. Negative 2x dx is my du. Stuff to the 1/2 becomes u to the 1/2. And I'm going to convert my limits of integration as well. So if x is 0, 4 minus 0 squared is 4. And if x is 2, 4 minus 2 squared is 0. And I can finish the problem without going back to x's. So the negative 3, I'm going to ignore. U to the 1/2 becomes u to the 3/2 divided by 3/2, and I'll evaluate that from 4 to 0. And so I get an answer of negative 3 times 2/3 of 0 to the 3/2 minus 2/3 of 4 to the 3/2. And I would stop there. If I were taking the AP exam, I would stop there. However, I am going to clean this up anyway. So 4 to the 3/2 is 8, so that's going to be negative 16/3, and we get an overall area of 16, unless I just did my mental math incorrectly there. So there's question A. It is known that for C equals that, they are giving you the derivative, that's ugly, for a particular spinning toy. The radius of the largest cross-sectional circular slice is 1.2 inches. Okay, what is the value of C for this spinning toy? Wow, okay. This is a doozy. I'm going to have to think about this one for a second. They gave you the derivative, the radius, and I don't think I'm allowed to screenshot the problem in these recordings, so that's why I'm not putting the problem up here. One year I screenshotted the problems as I worked them and was promptly told by College Board to take them down. So my figure looks something like this. We kind of have this little teardrop thing there. And if we're spinning that around the x-axis, the largest radius is going to occur at this maximum. Okay, so that is going to happen at the critical numbers of the given function, and that is where the derivative is going to come in handy. So that maximum is going to occur. That maximum is going to occur at an x coordinate where the slope is 0. So we need the derivative, which they gave me. So for part B, I need the derivative that they gave me. So that is C times 4 minus 2x squared over the root of 4 minus x squared. I need that to equal 0. And that occurs when 4 minus 2x squared is 0, which is going to happen when x is the square root of 2. Technically, negative square root of 2 is in there as well. However, we are in the first quadrant. So we now know this is happening at the square root of 2. Then they tell you that the radius is 1.2. So this distance is 1.2. And so now I've got to figure out when x is square root of 2, we need the function to equal 1.2. Yeah, we don't have a calculator. These little turd monkeys. Okay, so my function for the radius is cx square root of 4 minus x squared. But we do know that x is the square root of 2. At x equals square root of 2, that's going to give me the square root of 2 times c times the square root of 4 minus the square root of 2 squared. I'll plug it all in. So 4 minus the square root of 2 squared. That is supposed to give me a radius of 1.2. That's going to give me a distance of 1.2. We have to solve that equation, and it actually ends up being kind of nice. Square root of 2 times c. This ends up being the square root of 2 as well, is equal to 1.2. And when you divide by 2, c is going to equal 0.6. So there is your value of c. Wow, what a painful question. They're evil, evil. Those College Board people. They give you a nice question. They gave you a nice calculator question. That little particle motion thing we did earlier was nice. Then they come back here and they just completely kick your tail. Why did I not? What is this thing doing? I'm trying to shrink this up. Come on, work with me. There. Okay, so there's part B of the good old dreidel problem. I guess it's a dreidel. Dreidel, dreidel, dreidel. All right, for another spinning toy, the volume is 2 pi cubic inches. Find the value of C for this spinning toy. Okay, so they're giving you the volume, and so to generate the volume, this is going to be a disk. It's going to be a dx. The antiderivative of or the volume of a disk is the antiderivative of pi r squared. And the radius is the function here. So that's the radius. And so this would become pi antiderivative from 0 to 2. Because a long time ago, we found out that 2 was the place where was this point where the curve hit the x-axis of r squared. And if you square that, we will have c squared x squared times 4 minus x squared. Because r is this function, dx. We're going to have to solve that. And then they tell you that that volume ends up being 2 pi, and we have to solve that equation. So here we go. It's not going to be a terrible, terrible antiderivative. This c is a constant. I'm going to take that out altogether. Stick it in front of this pi. So I have c squared times pi. Then I'm going to distribute this x squared. That'll give me 4x squared minus x to the fourth. And I'm going to do the antiderivative of that. So that'll give me 4x cubed over 3 minus x to the fifth over 5 from 0 to 2. And all of this is supposed to ultimately give me an answer of 2 pi. And to clean this up an ever tiny, tiny amount, I'm going to divide the pi's out and get rid of those. Okay, we're almost done. C squared, I'm going to plug in 2. 4 times 8 is 32 over 3 minus 2 to the fifth is 32 over 5. I would subtract the 0. If you plug in 0, you will get minus 0. So maybe I'll appease the gods of math and write that in symbolically, minus 0. All of that is equal to 2. And I'm going to take advantage of College Board's policy on not simplifying answers. C is going to be the square root of 2 divided by all of that. 32 thirds minus 32 fifths. And there is your answer for C, whatever that ugly number is. My square root looks bad. All right, I think I'm done. I'm solving these quickly without a whole lot of double checking. And see, how much time do I have left on this one? So I've spent 9 minutes solving this one. So really, I probably should go back and double check that because I probably made a careless mistake somewhere. But whatever. All right, so there's number 3, and I hope that's the hardest one you ran into.